Hello, my name is Christian Lucas. I'm from Germany, from the State Office for Geoinformation and Survey. And I'd like to talk about the future concept for the German cadastre in the sense of land use and land cover. First of all, I'd like to give some information about the structure of German cadastre. It's a bit more difficult because the German cadastre, there are three data fields. The first one is the data from the real estate cadastre, and the data model behind combines the real estate book and the real estate map, and it's combined in the ALCES model, the authoritative real estate cadastre information system. And this A is one of these A's, and the other both are the information from the topography, the authoritative topographic cartographic information system, ATCIS, and the control point information system, AFIS. And all together are combined in the GeoInfo doc and gives the 3A model. The 3A model has some object fields or so, object types. These are the first one, the land parcels, the owner, the buildings, the actual use. And this is a field where a lot of the land use information. And then are about some information about structures, facilities, or relief, or legal specifications. The information for land use and land cover we will set in this field, in this object type. But at the moment, I would like to show an example to you to see how the information is modeled. Here you can see the scene within automobile test area. You see here some forest and grassland, and here the streets for testing the cars. And in Germany, with the actual use field, or with the actual use data types, you can model this situation by two ways. The first one is the data models from industry and commercial servers, to make a shape with industry and commercial service and roads. And the problem is the information is used for the tax administration or for environmental planning and for statistics. And the information from settlement and traffic, what is the same, is not this information behind, because there is a lot of forest. And so it's wrong information, more or less wrong information. So the second possibility is this one. This is more the cover-oriented modeling. That means you have industrial and commercial servers. It's just the part where the buildings are. Then you have forest here, and grassland, and vegetationless areas. And this one is also a type of modeling within this within the object types, but it's another information for the same area. And that's a problem, because in our data we have just one version. And the operator who gets the information, he takes a decision if it's more it's more a cover information or it's more use information. Yeah, that's the information from the same field for the tax administration. So, but to solve this problem, we like to introduce the land use and land cover within our data models. The same situation, and the new kind of modeling is to get the information in two levels, a land use level and a land cover level. Within the land use, we have the commercial service, and within the land cover level, we have the vegetation, woody vegetation, the buildings and the areas, the cover information also. So we have developed an object hierarchy to model such information. There are a lot of existing nomenclatures. Today you've heard about some Corel land cover, Hilux, Eagle, the Lucas administration. In Germany, we have also the land cover model for Germany. But all the nomenclatures focus on a specific aim. So you can see that in the land cover model for Germany. These are the classes for the land cover model. There are 15 classes for land use, 36 classes for land cover. But the classes are not original cover or use classes. So you can see here the land cover field, and there is some information like this. This is farmland, and farming is more the use information, not the cover information. And here is also an interpretation in the first field. You see the buildings with the ceiling rate, and the ceiling rate is processed. So if you need a ceiling rate of 40%, you have to use this class, and the information is interpreted. So it's a problem. So that is a land use field with 50 classes with living, and also, but it's not, the density is not enough for the German cadastre information. So the first challenge was to see what kind of information we need. So we have started with a semantic decomposition of the TN, the actual use object field, in the components of land cover and land use. The core question is how to do a semantic decomposition. But there's also a toolbox existing. So we have used Eagle concept, as a European approach to describe the landscape, with all the classes and the components. There are 32 components for land cover, 88 components for land use, and a lot of characteristics. And so you can take for every point good information about the land cover, the land use, and the characteristics. So this is a screen of the land use of the Eagle matrix you have seen already. But here we have an example for forest. This is a forest, and these are the fields which are affected from our current forest class. There are a lot of zero or empty fields. So when we merge the information, you have here the better view. This is a current class forest in our cadastre data. The object class name is forest, and there are a lot of attributes, like vegetation feature in hardwood, softwood, or hard and softwood. And there are also state attributes like funeral surfaces, and so on. And we have taken the Eagle concept and have looked how the information is about. And in a forest, when we take this example, here we have hard and soft forest, and we think in the class hard and soft forest, there are trees in the Eagle concept. There is a 2, and the 2 means that the components are required. Every forest has to be trees, has to have trees. No trees, no forest. Simple information. The next fields are scrubs. For forest scrubs, not so important, so there is a 1. So we think there are some scrubs in the forest, but without scrubs, forest is also forest. Next step here is the use information, and that's a problem in our current data model. We see here is a 1, so we have no good information about the forestry use. We think every object in our database, which is called forest, has a forestry use, but we don't know it. It's not explicit modeled. So there is information, it's more information required about the use. There we have the characteristics, and for an object, hard and softwood, the typical characteristics are the spatial structure. If it's mixed or it's mosaic. It's a mosaic. We don't know it, but if there are hard and soft wood, it is mixed or it has a structure of a mosaic. For a softwood forest, there's just homogeneous softwood, no mixed information. It's also a 2. And the last information we have is the leaf form. For an object with hard and softwood, we have needles and broadleaves. Both are required, so the three have the information that both informations are required. It's an and, so we need needled and broadleaves. Without both components, we have no hard and softwood. It's one of these. So in the first step, we have from all the information, approximately 480 classes. We have a semantic decomposition of the information which is in the classes. And there are some interesting facts, like this one. In our class, Sport, Leisure and Recreation, we have at the moment the land use information. This means all the meaning from the class is focused on the land use, on the sports, for example. The land cover components, which are here in a the kind of information of the land cover is not in the class at the moment. This information we can't get from our current data. So this is a gap. And that's a benefit of the new model. And because of the semantic decomposition, we know how big is the gap, how many information we are at the moment do not have. So, but the next step, we have the semantic decomposition. We need this kind of information to get back to our model and change our object, feature object types from the actual use to land cover and land use. LBLN means land cover, land use. For our example forest, we have the view of the eagle matrix. And coming from this, we have seen what kind of information we have, and we have to define new classes, which hold all these informations. So we know for our class forest, for the hard and softwood, we need a class with trees. And so we have our new land cover nomenclature. The woody tile includes trees. He also includes information about the needles and with the vegetarian information. The M means that it's a direct migration. So we have our current data coming from forest and hard and softwood, and we know, okay, in this class are trees with needles and broadleaves, so we can make a direct migration from the information to the land cover object, to a land cover object. The next information is the land use on this side. And there we have two object fields. On the one hand, we have the polygon, and on the other hand, the forestry use. And for an object, hard and softwood, we know, or we approximately, is there a forestry use? So there is an what means we have to control the information, but we think it's a forced use. There is some more information about here one attribute in current object IX forest can have is forest funerary surface. And within this class, we have here the broadleaves and the needles, and we do not know which one it is, but the information came from another attribute. That's the meaning of the K. So the first step, we can make a migration from our current information to the land use and land cover information. In sum, we have for the field of land cover 55 object types and feature types and attributes. In the feature groups, building, vegetationless, vegetation, water, and habitats. Here in this view, this is the view of the nomenclature in German, but there's some more information because there is a classification in green, yellow, and red for each class, if it's possible to get the information from remote sensing data. or from automatically remote sensing methodologies. So we see here are some attributes we can't get from remote sensing here as well. And there we have to take an operator who will give us this information manually. The green things we can, the information comes from remote sensing data. There is the same example from the vegetation. You can see better the colors. Our land use part is more bigger with approximately 300 object and feature types. Within the feature group settlement, traffic and infrastructure, agriculture, forestry and water management, and one class, no primary use. The interesting thing, there are a lot of classes. In some 351 for the fields land cover and land use. But actually in the feature types from the actual use are more. These are 475. So we have lesser feature classes in the new model. Now I will talk about some modeling principles for our new levels of land use and land cover. These are land use and land cover is independent to each other. The modeling is gapless and non-overlapping. The land use can be specified secondary with a secondary information layer. We have examples of this. And we have a topological network for of infrastructure lines. Here an example. We see here is a campsite in use. The campsite is on the use level, the land use level, and under the land side, the land use, we have the land cover level. And in the land cover level, there are the water fields, the building areas, or the vegetation. But both levels are independent from each other. So we see here is a water body, and the water body is not, the shape of the water body has no reference to the land use. The next one is modeling is gapless and non-overlapping. So between the objects, one object campsite, for example, and one object forestry, there is no gap, and they are not overlapping. They are the lead geometries. Then the land use can be specified by a second information layer. So the land use information in some parts, to get the land use information more detailed, we have defined that we can take a secondary use. For example, here is a camping site. And in the camping site, there is an auto pool in this field. And so it's possible to have a ground, it's a camping site, and about the ground there is an auto pool as a part of secondary use. And so we get very specific information from all possible situations. Then there is our scale. Our scale is really detailed. So the objects from the used objects with buildings has to be consistent with buildings. So if there is a building on an object, it has to be in land use class which is consistent with the building. For example, there's industry, the building for industry, so the shape down under has to be industry. Oh, yeah. You know. And for scale, granularity are shapes with 1,000 square meters. If a shape is bigger than 1,000 square meters, we have to separate the different use. That's information behind. In vegetation, for forests, we have the 5,000. To to separate needle and broadleaf forest, for example. Yeah, that means 1,000 square meters are the smallest objects, but if there's an object really important, like this, here is agricultural area, and these are not with 1,000 square meters, you can model it, you can hold it in the database. You can create this object, but it has to be really important. The normal size should be 1,000 square meters. So when we have done the cost estimation, so we have all the data and we have to migrate it. And the question is how expensive this is. And for the land use, we can migrate approximately 85% about the different groups. In the settlement, in the field of settlement, we have 82 groups we can migrate directly in our new model. For the water are 69. So round about 85% we can migrate. So it's not so expensive. The leaving 50% we have to create manually. For the land cover in Schleswig-Holstein are approximately 88%, but the intention is to get the land cover information from unit sensing. So this is just a theoretical calculation. Back migration is really important in Germany because the tax administration uses our data, and so we have a lot of users who want a back migration to the old model. And from a new model, we have a back migration rate of 95%. Exactly. Okay. Thanks a lot.